Okay, so start by putting your name at the top if you haven't already. You will be turning this in tomorrow, and it needs to be completed front and back. So we'll be doing one side together, but then you need to make sure to do the other side as well. Date today is 12/10/20. I'm actually going to be working on a larger copy because my handwriting will be better. Here we go. Okay, so the first one here, find the measures of angles A, B, and C if P and Q are parallel. So if these are parallel, this is the transversal here. If this is 42 degrees, this forms a linear pair. So 180 minus 42 would give you 138 degrees. So angle A is 138 degrees. Then for angle B, it is corresponding with the angle they gave you. So it would be the same measure, 42 degrees. And then angle C is a linear pair with that one. So 180 minus 42 would be 138 degrees. You could also say that alternate exterior angles are congruent. You could figure it out that way. When you look at these though, something that you might realize, it's either going to be one of two angle measures. It's either going to be 42 degrees or the supplement to that. So looking at this, provided they don't make it tricky so you can't see what's what, all the acute angles here are going to be the 42 degrees and all the obtuse ones are going to be 138. So it's a good way to check yourself. The next one, find X and Y if P and Q are parallel. So these two are parallel. I'll start by finding Y. I notice that these two form a linear pair. So 180 minus 93 is going to equal Y. Y equals 87 degrees. Then to find X, we have vertical angles here. You probably recognize this problem from your homework last night. We'll set them equal and then solve for X. Number 4, determine whether each statement is true or false based on the diagram below. It says A is parallel to B. Okay, is angle 1 equal to angle 4? Yes, those are corresponding angles and they are congruent. Is angle 2 equal to angle 4? Yes, alternate interior angles are congruent as well. 1 and 5 are alternate exterior angles and they are congruent. And again, if the names of everything confuse you, in this case, if they're obtuse, they're going to be congruent to each other. So that's a little trick. Angle 1 is equal to angle 3. No, they're a linear pair. They're supplementary. They are not equal. That's false. And you can also see that one's acute and one's obtuse. Angle 3 and 4, these two are consecutive interior angles. Those are supplementary. They are not equal. And then 4 and 5 are vertical angles. Those are equal, so that's true. Number 5, again, finding the angle measures. Let's see. This is 128, then the vertical angle from that would be 128. Alternate interior angles are congruent, so this is 128 degrees, and angle 1 is also 128 degrees. Then for angle 3, it forms a linear pair, so 180 minus 128 equals 52. So angle 3 is 52 degrees. Number 7, find X if BD is a perpendicular bisector of AC. Perpendicular bisector means not only is it perpendicular, which it forms this 90-degree angle, but bisector means it bisects this side, making both sides equal. So to find X, we can set those equal to each other and solve for X. Yeah, X equals 7. And it was only asking for X, it didn't ask us to plug it back in. Great. Now we're transitioning over into volume problems. For this, you may want to do the work on a separate sheet of paper because it gets really crammed, just FYI. I'll get my 150 here. Okay, so the instructions say find the volume of each figure shown below and round to the nearest tenth. So if we have to round, we're rounding to the nearest tenth. Says it's not multiple choice. Of course, the exam will be multiple choice. It's saying that you have to solve each one of these individually, not choose A, B, or C. So for this one right here, volume of a cone, the equation that they'll give you on the reference sheet looks like this. Volume equals 1/3 area of the base times the height. And it won't be labeled, you just have to recognize it. Then area of the base, in this case, is a circle. The area of a circle is pi r squared. This is not on the reference sheet, it has to be memorized. So we're gonna plug that in for capital B. 1/3. What's that?
What is on the reference sheet?
Mm-hmm.
Like, what is on the reference sheet?
I'll go over that at a different time. Okay. So here is the equation we're going to use to find the volume of this thing. It tells us that the radius is 3.9 and the height is 5.6. And then I can plug in numbers. I prefer using 3.14 for pi, but whatever you prefer is fine. Then radius 3.9 squared and times height 5.6. Once you have the numbers plugged in, you can solve it, but make sure to use order of operations. So this exponent will come first. So 3.9 squared, so I'm going to bring everything down. 3.9 squared is 15.21. And then from here, you can just multiply in any order. You can do 1 divided by 3 to get the decimal for this, times 3.14, times 15.21, times 5.6 to get the answer. I get this decimal. It says to round to the nearest tenth, so 89.2 is what I got. Centimeters cubed. Okay, volume of a cylinder. Volume equals area of the base times the height. The base is a circle, so we're going to plug in pi r squared times the height. And then I'm just plugging in numbers. 3.14 for pi, radius is 6, and the height is 10. Use order of operations to solve. And it comes out to volume equals 1130.4 centimeters cubed. Okay, we got that. The answer key says that the answer is 1131. Why is it saying it's something different? Because it rounded through. Yeah, I rounded pi to 3.14. If you use the pi button, you would get an answer that's slightly different. So whatever you get, if it's a little bit off from the answer choices, it's just because they used the pi button instead of 3.14. Also, as the numbers get bigger, so let's say you get into millions and stuff, the answer gets off more and more with rounding. So just keep that in mind. So if it doesn't match exactly, it doesn't mean you did it wrong. They just used the pi button. Okay, next one. This one's a pretty easy one. Volume of a rectangular prism is length times width times height. That's more of a 5th or 6th grade type question. Another way they might try to throw you off with this is with the units. So always make sure that the units are in the same measure. But they are in this case, so we can just multiply length times width times height. 20 times 3. Volume equals 60 inches cubed. Okay, number 2. Find the volume of the water in a rectangular kiddie pool that measures 12 feet by 6 feet. if the pool is 18 inches deep and the water depth is half of the pool depth. So I'm going to draw the pool here. This is a rectangular pool. It is 12 feet by 6 feet, and then the depth is 18 inches. Problem, we're in feet and inches, so we're going to change the inches into feet. 18 inches would be 1.5 feet. That's the height of the kiddie pool. But the question asks for the volume of the water, and it tells us that the water is halfway. So to find the halfway point, 1.5 divided by 2 would give us 0.75, and that's the water depth. So 0.75 feet. Okay, so to find the volume of just the water, volume equals length times width times height. So volume equals 12 times 6 times 0.75. Ooh, I shouldn't have used. There we go. And when you multiply these three numbers, you get 54 feet cubed. We're ready to move on to the next page. So I'm making them look pretty easy because I've already gone through the steps before, but the first time you look at a problem like that, it will take you a minute to kind of figure out what they want. And it'll take you more time than I'm showing you here. For the next one, find the volume of the square pyramid shown. Volume of a pyramid, just like a cone, is the equation volume equals 1/3 area of the base times the height. Same equation. The difference is the base is a different shape. So instead of finding the area of a circle, we're finding the area of a square. So volume equals 1/3 length times width of the square times the height. And then I'm going to plug the numbers in. The square is 12 by 12, and the height is 8. Once you get to this point, it's all multiplication. You can multiply in any order. Some people prefer, instead of multiplying by 1/3, just divide by 3 at the end, which is the same thing. So you can do 12 times 12 times 8, and then divide by 3 to get the answer. Number 4, this time they don't give you a picture, but it's the same problem, same type of problem as number 3. It says a building in the shape of a square pyramid, that means it's a pyramid with a square base, is being built in Las Vegas. The height of the building will be 309 feet, and a side of the base will be measured at 250 feet. How many square feet is the building? Okay, I'm going to draw like a little picture for myself of the pyramid. The height is 309 feet. It says the dimension of the base is 250. It also tells you it is a square pyramid, so the base is a square. So if you have one dimension of the base, then the other one is the same thing. And then you can solve for volume. So volume equals 1/3. Area of the base will be 250 times 250. And then the height is 309. So the answer comes out to a really big number, 6,437,500 feet cubed. Also, I think there was a typo in the problem. It says how many square feet is a building? It should be like cubic feet. Okay, next one. The diameter of one side of a 10-foot log is approximately 13 inches. They show that in the picture. The diameter of the other side is about 11 inches. Which is the best way to estimate the volume in cubic feet of the log? Okay, so volume of a cylinder is area of the base times height, so pi r squared times the height. It says in cubic feet, however, they're showing us inches here. So we have to change this into feet. It does say to estimate, so I would round 13 inches to 1 foot. So the diameter here is 1 foot. For the equation, I need radius. So radius would be half of a foot, so 1/2 feet is the radius. I'm going to round pi to 3. Radius 1/2 squared, and then height, just keep it 10.
Why'd you round pi to 3?
Because it says to estimate. Then I'm going to start looking at the answer choice to see what they're looking for. I know this is not it. The times 36 doesn't make any sense either. It's between these two. 1/2 squared, 1/2 times 1/2 would be 1/4. So therefore A is the correct answer. Number 2. The figure below shows a 20-foot tall evergreen. So again, I'm just going to mark it up. 20 feet tall evergreen with a 1 foot wide trunk. The lowest branches are 3 feet above the ground. So that means this dimension is 3 feet. And at that level, the tree is 7 foot wide. So the leaves are 7 foot wide here. Indicate, what does it say? What is an appropriate shape or combination of shapes that can be used to model the tree to estimate the volume of the tree? Indicate the dimensions of the shapes. Okay, so the shapes I see are a cone for the top part of the tree and then a cylinder. So I'm going to write down cone and cylinder. Then it says, okay, what dimensions would you need to estimate the volume of a cone? You would need radius and you would need height. So for the cone, the radius would be half of 7, which would be 3.5. And the height would be 20 minus the 3 here to get 17 feet. And for cylinder, the base, you would need radius and height. The radius would be half of 1, so just 0.5 feet. And the height would be 3 feet. It doesn't ask you to solve anything, so we're done at that point. I don't know if on the exam it would have you solve something, but also if they were to show me this image on a computer, I would almost have to like jot it down on a piece of paper to show all the dimensions because it would be hard to see it all without it being drawn. Yes, Julie. And when we're done with the next 2 questions. We're almost done. Okay. Lewis is going to form a clay model of a skyscraper shown here. The model will be in the shape of a 2 foot tall prism and 6 by 6 inch base. The clay he will use comes in containers shown below. What is the least number of containers Lewis will need in order to complete the model? So this is a model he wants to build. This is the size of the container that the clay comes in. He wants to know how many of these he has to buy to make this model. So you have to find the volume of each and then figure out how many of these you have to buy to fill the volume of this. So we're going to start with the volume of the skyscraper model. Also, volume equals length times width times height, as you know. But we're in different dimensions here. It's showing feet and then it's also showing inches. So I'm going to change this into feet. That's what the answer key does, so we'll go with feet. You could also change everything into inches as long as it's consistent. 0.5 feet. So then when I find the volume, 2 times 0.5 times 0.5. Half of 2 is 1, and half of that is 0.5. So the volume is 0.5 feet cubed. Then for the cylinder, volume of a cylinder, pi r squared for area of the circle times the height. it says that the containers are a 1/2 foot tall, so 0.5 feet tall. And the base has a diameter of 1, so the radius would be 0.5 as well. So the radius 0.5 squared times the height, which is 0.5. When you multiply these three numbers in a calculator, you get 0.3925 feet cubed. So it's asking how many of these do we have to buy to make this? Well, at least one. You'd have to buy 2 containers. If for whatever reason you needed a more specific number or it wasn't so easy to tell, you could just take the 0.5 and divide it by 0.3925 to figure out how many times that would fit into there. And it fits in 1.27 times. But you can't buy 1.27 containers, you have to buy 2. Almost there, y'all. Okay, Santana won the design contest for the new mascot image that is to be drawn on the football homecoming field banner. Her original diagram measured 10 inches by 5 inches, with the mascot height of 4 inches. So this guy is 4 inches tall. The actual homecoming banner, the larger one, will be 12 feet by 6 feet. How tall should the mascot be? So what we have to do is figure out how many times bigger this is compared to this, and then we can take that number and multiply it by 4 to figure out how big the mascot will be. Problem is we are in inches and feet. We need to be in all the same unit. So I'm going to change this into inches. 6 feet, 6 times 12 is 72 inches. And 12 times 12 inches in a foot is 144 inches. Now I'm going to take 72 divided by 5 to figure out how many times greater it is. 72 divided by 5 is 14.4 times bigger. And then the mascot in the original is 4 inches. I need to multiply that by 14.4 to get 57.6 inches. But you go to the multiple choice, 57.6 is not there. What else could be there?
58.
Well, how many feet are in that? That would be, there's 4 feet there. 4 feet, 57.6 minus 48 is, so 4 feet, 9.6 inches could be in the answer choices. Also, if you took 57.6 and divided by 12, you get 4.8 feet. Okay, so that's the entire side. Yes, you can go to the bathroom, Julie. So today or tonight, you'll have time in class to do this. You need to finish the other side. I've already uploaded a video for the other side that you can use to walks you through it. There's also the answer key with all the work, so whether you like the video style with everything explained or you like to look at the work and figure it out on your own, that's up to you. So you need to finish the other side, and you need to do exam review homework number 4. Remember, the exam review homeworks, a lot of those questions are from the exam reviews we've been doing in class, so if you get super stuck, look at your exam reviews. If you're behind on your homework, you need to get caught up, but I would recommend doing them in order that they were assigned because they build. Any questions? If the computers aren't working, so if we get on the computers, they aren't working, then you'll use the rest of class to fill in the other side, and I'll just project the page up. Cool? Okay. You can start getting the computers. Thank you.